sometimes they don't use all the same formulas that we do, and I think that inverse tangent is one of them. So this becomes 1 over 1 plus domain squared. It's really important you don't just put x squared. It's whatever the domain is in this case, which is the 8x over 5, or 8/5 x. Then it's times the derivative of this. Yeah. I hate that notation. I can't stand that notation, but all right. I noticed your book uses it. It makes me mad. And then times 8/5. So good job. If you wanted to clean it up, yeah, wow. Well done. That's a lot of work. Next up, we have this here. I just want to make sure I read the problem correctly. It's this equals this. Is that the original problem? Yes. Okay. So first we have to do quotient rule, which is not cool. So we have 1 plus y prime, x, okay, good, minus, yes, over squared, yes, good, good. And then I'm going to assume the algebra is correct to shuffle out this here. You're going to have to do distributive property here. You're going to have to dig all these y primes out and then get everything to one, factor out the y prime and divide the whole thing by that, which I'm assuming is what went on here. I'm not going to check all the algebra there. I'll let you guys play with that. 18. This is the original problem?
Yeah.
Okay.
Sorry, can we go back to 26?
Yes, we can. Sure.
Just how far do we need to go to get it complete?
I need y prime by itself.
You need y prime by itself?
Yeah,
okay.
so you do have to dig out the y prime. I know I'm a little loose on some of these other ones, but if it says I need dy dx or y prime, then I really need that done out.
Then for derivatives, which one the other derivatives, would it be like you can stop where the quotient rule is?
For right now, if it's just do the quotient rule, then you can just do the one step and stop.
Yeah.
Okay? We will clean stuff up eventually, and that'll be important. But for right now, I just want to test you guys. Do you know how to do quotient rules? Do you know how to do product rule stuff, and not worry about the algebra stuff? Is that clear enough? Okay, next up, 18. So you have to do product rule. Here and here, very good. Minus product rule again. That's the good use of the parentheses here to make sure that you do distribute that negative in there. That'd be very easy to miss. Minus. Yeah, you're missing the closed parentheses. That's okay. And then if you want to clean it up, like it looks like some of this is getting cleaned up, that's fine. That's great. This one here, yeah, you may want to rewrite, you may want to rewrite this like that. If you can't see that ahead of time, this person could, which is fine. And then derivative. Oh, look at the second derivative. Okay, very good. And again, I like writing this as e to the negative second power. And I like leaving my answers in this form here, because if you do have to do a second derivative, it's right there. You don't have to play around.
So if you do a derivative of a denominator, you can just like add one?
No, you still subtract one.
No, but like if it's, you know what I'm saying? If it's in the denominator.
Oh, in the denominator?
You just add one.
Yes, because it's opposite.
Cool.
And be careful with that thinking, because eventually when we get to going in the opposite direction, the adding one, that might get a little confusing. Because there's another rule that when we're going the opposite way, instead of subtracting when we're adding one.
Okay.
So just be careful.
Cool.
Number 14, I did. If you guys find a mistake, please tell me, but I think we're okay. I should double check it.
Yeah.
I don't know what number this one is.
36.
Oh, no, I missed that. 36. We're there. Good. I like rewriting it like that. Excellent. A. Is this the?
Oh, you broke up 14.
This is the linearization here.
Yeah.
Okay.
You just
Good.
broke up 14, right?
What's that?
You broke up 14, like 3.
Yeah, I like breaking it up into 3 separate pieces.
Cool.
The original person that put it up here put it into quotient rule, which you could do. It's just very, very messy. I think you're supposed to find the equation of a line here.
Yeah.
So let's finish this up. So we have the slope is 3/4, and your point is here. I'm sorry? I can't hear it.
I just said, oh, find the y-intercept. I'm just kind of thinking out loud.
Yes, that's right. That's what we need to do. So I like just plugging it straight in. So this is going to be 5 halves. M is 3/4. X is 2.
It's one.
This is getting a little messy here. That's going to be 2.
It's one, isn't it?
So that's going to give me 5 minus 3 is 2 half with 1. M is 3/4 x plus 1. So that's going to be your final answer, 4/36. Make sense? You can use that point slope formula. I usually avoid that. You okay? All right, next up, number 40. You can stop here. This is okay too. You guys are mocking me, aren't you? So they brought this up to make this product rule, which is great. I probably would do the same thing. So product rule is going to give me, there's the x, and then good, the 7. We're missing the other half actually. Plus 7x plus 1 to the negative 1/2 power. So this is fine here, but you can keep going. So they're missing the second piece here. Because the product rule says that we're going to do derivative of this piece, which is there, times here, which is x, plus the derivative of that, which is just 1 times that. So this is not right. Sorry, I'm going to stop there. It says it's okay. Oh, that's you, right?
That's
okay.
me.
So
That's not a
that's
problem.
I am not a problem. There's 35 too down here. I don't know if you saw.
Yeah.
Underneath 36.
Did I miss 35?
Yeah.
So this one I skipped a step. It should be 1/2 times radical that. Then because of chain rule, I get that extra 2 here and I reduced them. Do you see what I'm saying?
No.
You're supposed to get it. Okay. So
You can erase the, but this is okay too.
that's okay. This is essentially the same thing, right?
Mm-hmm.
So y prime is going to give me 1/2 times 2x plus 36 to the negative 1/2 times 2. Because of chain rule.
Yeah,
The 2 there.
that's much better.
So the 2's reduced out, and then I brought this down.
Yeah.
Which is
Okay.
how I got that.
Uh-huh.
This is also a linearization problem. And they wanted to know at x or a equals 0. With 0 there, that gives me square root of 36, which is just 6, so 1/6. When x equals 0 here in the original function, so I can get my y value, that gives me 6. And actually, this is the y-intercept, so I didn't need to go through all this work, but it's there if you need it anyway. So we're at 39, I think. So that is product rule. Product rule, that's going to give me, we're missing the second half there. So I don't like this. So here is the original function. This is also the original function, but you're saying that it's the derivative, and it's not. Do you understand what I mean by that?
Yeah.
So this actually should just be y.
Or d over dx.
No.
Not yet.
No?
Because we haven't done the derivative. All we do is just rewrite it with the 1/2
Okay.
thing.
Right.
Now when I actually apply the derivative,
Then you can add it.
again, you're missing the second half here.
3.
You can't do one piece of the derivative and say equals. It's got to be the whole thing. So even though these two are now the same, you can't have that and then something that appears and call them equal, because they're not equal, right?
Right.
There's part of something in one and not the other. Number 6, no, man.
Is that far enough? Dude?
Yeah, that's fine. That's fine
Yes.
for now.
Thank you, dude.
Later we'll.
On the
Then I'll
homework.
embarrass myself with the algebra.
Oh, so the homework made you.
The homework would accept this.
Really?
The homework is designed, the online system is designed to accept any variation of a correct answer. Every time someone has shown me a counterexample, there was a mistake in the answer. Okay, so, here. Alright, 38. Number 6. 6 I did. 38. So we take the derivative, we get cosine. This is again a linearization. I'm going to assume that that's all good.
And done.
This is at 0? I never thought about it. If this line is tangent at 0. Kind of cool. So actually, this is the diagonal line here.
Yeah.
Number 13. Someone lift an eraser up here, by the way.
That's mine.
Lies.
All right.
Occupied calculus over here.
This is the original problem here.
Yes.
Okay. Good. Yeah, that's good. 17. 7, pardon me. 7.
You only have to go to the
Oh,
first
right.
step.
Okay.
Step 1, we're done.
Yeah, you just go to there, it's fine for right now. And this is number 8 here. So, is this y equals, I'm assuming?
Yeah.
And,
Y prime equal, yeah.
and done.
Y prime dy dx, same thing. So derivative of the top, 2x minus 3, good, times, that's the 7th power?
Yeah.
Okay, yeah. Yeah, looks good.
And
Well done.
step 1.